Hello and welcome to the next tutorial on PIC microcontroller implementation and configuration. We will be going through what I like to call the Blink project, which is where we're just going to be simply taking a PIC microcontroller, one of the smaller ones, the 16F family, so 8-bit microcontrollers, and we're going to be hooking up an LED to it and writing some simple code using the CCSC programming language and just making an LED blink. And I'm going to be going through the hardware construction as well as the software implementation. The chip we'll be using today is the 676 PIC 16F. Here's kind of a small diagram of how the pin layout is. You've got your VDD and your VSS, so your power and your ground. You've got all your I/O pins and whatnot. And if we scroll on down, every data sheet has this, or should have this, but it has a block diagram, which is kind of helpful in knowing what kind of architecture your device has. This one has a couple of ports. It's got A and C, 6 pins each for I/O. It's also got an internal oscillator, which is helpful. That way it saves you some pins and saves you from having to add an external crystal clock. However, if you do need the external crystal clock, you can use one. You just hook it up to these pins right here. And that way, I think the internal one goes up to only 4 megahertz or so. So if you need any higher than that, you can always hook up an external one. Timer 0 and timer 1, a couple of timers for you to work with. Also an analog digital converter. This is very helpful for using any type of analog peripheral device that you may have to set in, so any type of potentiometers or just any analog device you can read into your system. So that's basically kind of a very short and quick and dirty overview of your device, the 676. So let's go ahead and get into the hardware design for our application. I'm going to be using a 7805 voltage regulator. It's very nice for voltage regulator. I use it in many projects. It can regulate from around 35 volt down to 5 volt, which is 5 volt logic is what the PIC uses. This is nice for if you want to do 24 to 12 volt to 24 volt applications. It works very well for those. The main thing that we're going to be doing is, the main thing you want to remember in building these is noise. Noise is a major problem. You don't want your system going unstable. So these two capacitors are very important to put into your system. On the supply side, if anybody's worked with any type of power supplies, they're not perfect. They have some noise with them. Some are better than others, but just to be sure, we put in a 100 microfarad capacitor on the supply, and then we go with a, that way it bleeds most of the noise down to ground. Then on the V out for our 5 volt side, we want to put a 0.1 microfarad capacitor on that side to make sure it takes care of any other noisiness that may have come through. We then connect our VDD, so our voltage, and our VSS to ground. We then connect the Mem Clear Pin. The Mem Clear Pin is basically a reset pin. You can reset the device without actually having to power cycle it. You can place a switch in this circuit, and basically a push button switch so that you can reset it if need be. For our application, we're just going to tie that to a high through a 10k ohm resistor to make sure that stays at 5 volt, because 5 volt will enable the chip to allow it to run. However, I'll show you later, there is an internal fuse setting, or basically a configuration bit that you can set that will internally tie that to a high and save you the resistor. If you know your application, you're not going to be using a reset button, then that'll save you a component. But for right now, I just want to get you used to seeing that. Later projects will probably be using the reset button, and so we'll need that 10K, so just get used to seeing it. Over here, we're going to just pick a pin, pick an I/O pin. We're going to use C0, and we're going to hang our LED off of it. And we'll just use a little 470 ohm resistor, hang that LED right off of there. Yeah, those of you, if anybody hasn't worked with LEDs before, you always want to take and put a 470 ohm resistor or something, some sort of resistance in between. You don't want to ever just drive it straight off the pin. They'll sometimes sink a lot of current and cause them to burn out. So you always want to kind of shunt them with a resistor. I like 470 ohm. You can go higher than that. It's just, it'll just dim down a little bit, which doesn't hurt anything, but it makes it a little dimmer if you go higher than that. So I like it to be nice and bright, so I use 470. And that's pretty much it for the hardware design, how to hook it up. It's fairly simple, fairly straightforward. So now we'll move on to software, and we'll run over here to our MP Lab IDE.